Okay, students, here we have the worksheet that'll be your assignment for today. Please do note that it does have some constants listed here on the front page for the specific heat of water at its different states, as well as a couple other substances. And then it also gives you the heat of fusion and the heat of vaporization. Make sure we pay close attention to the units that are here. As long as our units cancel out, then we are good in determining the actual amounts of energy. The question I'm going to actually work with you is actually going to be on the back side of your paper, but notice that on most of these are very straightforward and asking what you want, and number 13 actually walks you through step by step how to find the answer for that question, which is essentially what I'm going to do with the problem that I'm going to work out with you. So if you look at the back page, I'm actually going to work number 5 with you. And what this says is you have a sample of H2O with a mass of 23 grams at a temperature of 46 degrees Celsius. They want to know how many kilojoules of heat energy are necessary to do all of these things here. Okay, so what becomes important is, again, that we're able to pick out the information that we need. So we know that it tells us the mass of the substance is 23 grams, that our temperature is minus 46 degrees Celsius, and this should be our initial temperature because that's what we're starting off with, and they want to know how many kilojoules. The part that's important to know with this is that 1 kilojoule is equal to 1,000 joules. Okay. When we look at part A, the question is asking us how much kilojoules of heat energy are needed to heat the ice to 0 degrees Celsius. So what that means is that we would have our initial temperature here, and the 0 degrees then would essentially become our final temperature. Okay, so the only thing they're asking us to do to this point is just a standard specific heat problem. So using the specific heat of water, how much heat is necessary to take it from minus 46 to 0. Okay, so we know that our heat is equal to the mass times the specific heat of water times the change in temperature. Okay, in our case here, it tells us our mass is 23 grams, and in this case, because our specific heat is actually listed in the form of joules per gram degree Celsius, we don't have to convert to kilograms, so we can leave it just as is. So that would be 23 grams times our specific heat, which on the front, the specific heat of ice is 2.06 joules per gram degree Celsius. And then if our temperature changes from minus 46 to 0, then our temperature change is 46 degrees Celsius. Okay, so that's all I'm going to need to do to solve that problem. I would go through and punch that into my calculator to get my answer. Do note that this is going to be in joules, so whatever I get, in order to convert it into kilojoules, I'm going to take whatever answer I get here and divide it by 1,000. Also take note of specific figures. If you look in the problem, each of these have 3 significant figures. That means my final answer should have 3 significant figures. For part B, this is asking how much energy it's going to take to melt the ice. So all I'm doing here is the ice will actually be at 0 degrees. Remember, to melt the ice, the amount of heat energy needed is the heat of fusion, which we find by taking the mass times the heat of fusion constant. That's how much heat energy it takes to melt the ice. So in our case here, our mass we already know is 23 grams. And our heat of fusion from the front side, if you look at your constant, is 334 joules per gram. So my grams would cancel, leaving me with joules. They are asking for kilojoules again, so once I've done the multiplication, I need to go ahead and divide by 1,000 in order to give me the answer in kilojoules. Okay. For part C, it wants to know how much heat it takes to heat the water from 0 degrees to 100 degrees. So this is to make it go from when it's turned to a liquid to right as it starts to boil. So again, I'm going to use my standard equation. I don't have a phase change yet because it doesn't say to melt or to boil the water on there. So I'm just looking at how much it is for the temperature change. So my Q is still equal to mc delta T. In the case here, I know my mass is 23 grams. My specific heat of water as a liquid is 4.184 joules per gram degree Celsius. And then my temperature change, if I look here, it's saying my 0 degrees, this is my initial temperature, and my 100 degrees is my final temperature. So my temperature change from 0 to 100 would be 100 degrees Celsius. Again, since they're asking for kilojoules, whatever answer you get here, you want to divide it by 1,000 and then determine your number of significant figures. To boil the water. If I want to boil the water, they're asking how much heat does it take to change all of the water from liquid to a gas. So that's going to be using my heat of vaporization. So when I use my heat of vaporization to calculate that, here's my constant. It's 2260 joules per gram. To find that, that would be my mass times the heat of vaporization. If I plug in my values for that, I have 23.0 grams times my heat of vaporization, so 2260 joules per gram. Multiply that together. When I get my answer, to get it into kilojoules, I need to divide it by 1,000 and then calculate my correct number of significant figures. Okay. The last part here, to heat the steam from 100 degrees to 109 degrees, this is the last segment of the temperature change. So now I've already boiled the water into a gas, and I'm heating the gas from 100 to 109. So again, this one would be my initial temperature change. This would be my final temperature. So here I'm going to use my standard specific heat formula, MC delta T. I have 23 grams of the substance times this time my specific heat of steam, which if I look on the front, it tells me is 2.02 joules per gram degree Celsius. And then my temperature change, if I go from 100 to 109, my temperature change is 9 degrees Celsius. So again, I'm going to calculate my answer, divide it by 1,000, and then round to the correct number of significant figures. Okay, so I know that's a lot of work for number 5, but it does take you step by step. When you look at number 6, it is essentially the same thing. You have it going from minus 15 to 105. So you're going to have to break it up into the different segments, just like you did on the first part. So you're going to have to look at how much heat it takes to take it from minus 15 to 0, how much it takes to melt the ice, how much it takes to heat it from 0 to 100 degrees, how much it takes to boil it, and how much it takes to heat the steam. Okay, so hopefully you're able to follow this one here. If you just want to use my calculations and just plug in your final answers, if you don't want to rewrite all of this, that's fine, but use those same steps to help you solve number 6. On the front side, these should be much more straightforward and pretty much single step problems, especially number 13. So this one, it will work very similar to number 5 and 6 on the other side. So I hope this helps. If you guys do have questions, please send me a note on Edmodo and I will do the best I can to help you guys. If you have any other questions, I will see you guys tomorrow. Have a great afternoon.